This is my suspension setup, and today we'll be looking through it, looking at its components and just walking through the general construction of this setup. Starting from the top, we have the upper spring mount. This is what the top of the spring is fixed to, and it lies on a screw that allows it to be rotated left and right. As we rotate the upper spring mount, it slightly nudges the spring up and down. What this does is changes the initial compressive forces on the spring, essentially allowing the user to change the ride height of the car. On top of the mount are 3 screws that allow it to be fixed onto the chassis of the car. Because this is a performance suspension, it does not have a bearing mount at the top. Instead, the suspension is directly attached onto some sort of racing geometry, such as a double wishbone setup. Moving down, we have the dampening rod of the suspension. This is the rod that actually displaces the hydraulic fluid and slows down and absorbs the shocks. It is made of 3 critical components: the shaft, the plate, and this is what actually does the diffusing, and the nut. This rod is placed inside the damper cylinder of the suspension. Within this cylinder is where the hydraulic fluid is placed. As you can see, it is free to move up and down from the rod itself, and it is moved through the forces that are applied onto the car. Around this dampening cylinder is where the preload adjuster is placed. It lies on the threaded surface of the dampening cylinder and is free to move up and down. As it moves up and down, it changes the load on the spring, and essentially, like the upper spring mount, changes the ride height. But unlike the spring mount, this has a much more vigorous effect on the ride height of the car. As we bring into the equation the spring, we can see as we move the preload adjuster, the rest of the spring changes as well. This represents the changing load on the spring. To change the range of motion the spring has, we can change the preload adjuster of the suspension. What this does is lowers the ride height of the car and stiffens up the spring so it has less room to move. Fixed onto the dampening cylinder is the lower body of the suspension. It has 2 knobs representing the compression and rebound levels of the spring. These knobs can be rotated to change its level of rebound or compression. The knob itself has 2 parts. Fixed onto the rubber casing is the control. This changes the mechanical components inside to change the level of compression or rebound. On top is the knob that is easy access to the user to change the compression and rebound levels. Finally, on the bottom of the lower body, we have the bearings. These bearings are fixed onto the axle of the car and ultimately allow the suspension to move through bumps and cracks. Because we have designed this CAD model using multiple different components instead of one solid fixture, we can test the ability for each individual part to perform under different situations. For example, we can hide the other components except the dampening rod to test how the dampening rod will face under the compressive forces as it pushes down hydraulic fluids using the load feature of Fusion 360. To conclude, this is a performance suspension that is fixed onto a car. It features a top mount that changes the spring's compression, as well as a bottom mount that does this in more effect. It has the ability to simulate the conditions of a car, and even has rebound and compression knobs to simulate the way they are used in real life. It has multiple components so that it can be used in simulation, and is a complete setup that can be put into a car.